Well, thank you everybody for coming in and attending this particular session. I'll ask you all to take your seats because it's a little distracting if you keep talking. I'm going to pull out the school marm in a minute. Well, welcome everybody, and it is my absolute delight to welcome you all to this particular breakout session on how research infrastructure can enable translation of the research that we see coming through our doors and to make it real world impacts. So we've got 50 minutes, and I've got 4 people who could easily take 50 minutes on their own. So we are going to try and squeeze their knowledge out of them in a much shorter period than that. The whole idea of this session is to try and look at the underlying structures of our business models that actually provide or put in barriers to people who want to translate research. How do we help them do that? And what are the things that actually make it harder for people to do that? So we're going to start across our panel, and I'll ask them individually we're going to have a few slides from each of our panelists. And on those slides, we're going to introduce themselves and who they're representing here today, but also what is their big idea, or what is the thing that works from their particular business model and in their research infrastructure that does support translation, or what is it that really doesn't work. Once we go through those presentations, I have a couple of questions here that I will start with, but I also encourage you all to think about how these topics we can ask questions to expand on these topics and really share what our research infrastructures can do together to promote what research infrastructure is capable of enabling. So first off, I will introduce Professor Taketa Masaki, who's the president of the Photon Science Innovation Center in Japan, and he's going to present his business model for his center. So, Masaki.
So good afternoon, everyone. So I'd like to present my talk like this. Okay, transformative placemaking for building a new range of innovation ecosystem. So what you see here is Anyway, so what we have here is our research infrastructure, synchrotron radiation facility. It's brand new, and we just started the utilization from this April. And this has a new business model as introduced by the leader. And so what I'd like to say is the research infrastructure is not our goal. Our goal, how this infrastructure provide to solve the social problem with the industries. So how to make a place for the co-creation in between the academy and the industries. I will tell you what I mean by that. Okay, so what is the role of the synchrotron radiation facility for innovation? So providing the state-of-the-art experimental environment. It's a general, okay? But the transformative placemaking for innovation. What you see here is a placemaking is upgrade the probe to accelerate materials or other materials characterization, and the place branding, and promoting the industry academy, and the place development, creating a diverse community. So that's the overlapped area. From this overlapped area, the innovative idea will come out. Okay? So this is our concept. So our mission is to usher in innovation ecosystem, what you see here. So our facility, various stakeholders get together now. But the importance is what will connect these various stakeholders. That is the data, but data should be understood by everyone, every stakeholder. So our nanoterrace facility can provide by the new technique of the imaging and the visualization. I will skip about the technical things, but from the viewpoint of the management, so that our facilities construction have been achieved by the public-private regional partnership. That is the point. I will show you the detail. So far, such kind of the research infrastructure, the government pays the money, whole money for construction. But this time, only half of the money comes from the government. And another half we collected with the local government and the university and Economic Federation of Tohoku area. And we asked the companies of Japan to pay the money for construction money. As a result, the 150 companies, those are the major companies, agreed to invest to our facility. So that's changed the world to how to use the research infrastructure. So it's we provide the proprietary use, but what you see here is these beam lines. Yes, so our facility has 10 beam lines. We start with the 10 beam lines. And the 3 beam lines that provide the 3 types of the measurement technique, and we use as a public share utilization. It's a normal thing. But our new thing is coalition beam lines. So that these 7 beam lines offer that's a very important measuring technique for industries and academies. So the key word is this coalition, the new combination to unlock the power of industry and academy. And the coalition concept, this is a new scheme to disenthrow a waiver for members' proprietary use. So the incentives to concentrate on your R&D and to promote the challenge-driven research. So that we offer no peer review, and machine time is guaranteed. And members own their measurement data and result. So they can keep the data in secret. So that's a coalition member. As a result, as I told you, we have 150 industries. And the principle is company name is not disclosed, okay? And the disclosed company, Bridgestone, Sumitomo Rubber Industries, it's a Dunlop, and NTT, and the Polar or something. So the many big companies joined to our concept. And on the other hand, the academia, not the individual professors. Research institutes also joined as a private sectors. And to co-create the new challenge. So as a result, what you see here, conventional type of the utilization of the synchrotron radiation research infrastructure, so that the economic impact is very limited. But our coalition is creating the new ecosystem for innovation. So that the management of the coalition of real non-special, it is for non-real specialists. And a new attempt to reconstruct the missing link that leads science, technology, and innovation into a social implementation. So what you see here is a day one landscape of our facility. You will find that industries start as a collaboration with the universities, and the industries executives joined to the experiment and to solve their own problem. And what you see here is a food company. Okay? Food company is a new research area. And we change, our challenge is changing their insight to the research infrastructures. What you see here is a comment, message from the president of this small noodle company. So the Nanoterrace is here to make our vision reality. We use Nanoterrace as a mean for our company to do what we want to do. So the premise is that we can picture the sink where what we want to do in our company. So there are some things that can be understood by converting and visualizing them into data. So we realize that our concept is expanding to that from conglomerate, large company, and to small companies and the local companies. So what we are doing now. Thank you.
Thank you very much. And I'm going to move swiftly on so we get through this part of the panel very quickly. So I will ask Hank to join us. And he is the Director of Strategic Development, Environment and Infrastructure at BATEL, the National Ecological Observatory Network. So thank you.
There we go. Great. I'd like to thank the organizers for bringing me on board here and the projects that I'm representing. And I'm going to talk about some lessons learned about two projects and how we're bringing that to bear and developing a third project. And it's really about managing the human capital in innovation. And so just to give you I was asked to give a little context about the projects that we stepped up. One is NEON, the National Ecological Observatory Network, funded by the National Science Foundation, managed by BATEL. I was brought in as the second hiree to architect some of this. And it's a large distributed ecological observatory that has over 81 sites and 180 different data products in aquatic systems, in terrestrial systems that are stratified across the landscape of the US, that are designed to scale as well in time and in space, adopt a cause and effect paradigm, and designed to enable an ecological forecasting. So we've been providing these data for a long number of years now, but to develop it and to get to this point was a few decades. We also provide research support. So if all the things that we measure might not necessarily be what's needed by the research and education communities. So we also have the capability for other projects to hang projects on our system and our backbone and our data acquisition system. So we can accommodate lots of different projects. Again, we work from Alaska, the North Slope of Alaska, down to Puerto Rico, from Hawaii out to New England, and all the soils and ecosystems in between designed to scale. We've got remote sensed aircraft to be able to also measure the DEM, the digital elevation models, hyperspectral reflectance, to be able to take our site-based ecosystem data and then scale to larger areas and to the size of pixels and to merge that with satellite data. The other project that I just want to give a little background on is that now that we've designed something of this magnitude of a large ecosystem research infrastructure, the bubble in the center there, we also recognize that the data that we create is really synergistic with other projects, other long-term research networks, PI-based projects, coordinated networks. And it's really the integration of all of these that push science forward. It's not just being able to have long-term consistent data from a research infrastructure, but being able to merge that with others and the value add that can create. So towards that end, we've started something that's called the Global Ecosystem Research Infrastructure. If you were here in the last meeting, you heard Emmanuel talk a little bit about that, where we're actually starting to federate the data across large-scale research infrastructures. So not only are we going to be able to ask questions at the continental scale with consistent data, but we're also being able to ask questions across continents in the same way. This project is also funded by the respective organizations and infrastructures that you see here, including TURN and ICOS that you've heard talk about previously. But also we've got some additional support from NSF to be able to start federating those data around particular use cases. In this one, we're doing one for ecological drought and mapping that across the different ecosystems here, infrastructures here. If you want to hear more about this project, we've got a side meeting on Thursday afternoon. Take a look, everyone's invited. But I just wanted to give you the context that in both of those instances, both in developing NEON and in Jerry, we did not necessarily design and bake in the ability for translation from the get-go. But we recognize that there's new software, there's new approaches, there's new data products. So we have built in the ability to be flexible and to work with industry, private sector, and develop new products for research and for societal benefit. However, when we think about translation and what we want to be able to either commercialize or develop new products with other agencies, et cetera. The way of gluing together the data or the scientific challenges or the technical challenges, yes, they are there, but we've got models on how we are able to deal with them. We don't have models to be able to deal with the cultures that are required to bring all of that together. So put another way, when we're constructing and operating NEON initially, it acted like a startup company, a construction company, an engineering company, an academic institution, and we had to really explicitly manage all of those together to be successful. And that was extremely difficult. The same thing with managing and building the Jerry is that each of the research infrastructures internationally also have their own ways of doing things, their own cultures that they bring to bear that have to be explicitly managed. So if we're thinking about a new, potentially sustainable paradigm for translation, often what we see, at least in the world of environmental science and ecology, is the model on the left, where blue is the research infrastructure, and the private sector innovators are ones that are in yellow. And say if somebody's got a new widget, a new data model, or something that they want to be able to commercialize, it's really based on trust. Again, that's the first thing that somebody that's going to be out there, you know the industry, you know the person, you have that contact, that you're actually going to be able to put something out there. It's haphazard, it's happenstance, sometimes it's serendipitous and it works out, and other times it doesn't. We're moving towards other areas where there's private sectors activities or technology or an approach where multiple research infrastructures are looking at that, of saying, how can we use that? AI is a perfect example of that. But really, on how do we manage the culture to be able to infuse all of those cultures and from the get-go, and having a process to do that within an infrastructure that includes a private sector or commercialization from the get-go. And I think there's actually fairly few examples that can actually do that. This one is what we're working on right now. This is National Park Service that wishes to use a very interesting location that is called it's an airstrip right outside of New York City in Brooklyn. I grew up in New York. I didn't even know it existed. And they have a variety of different coastal environments. And so looking at mandates, again, from OSTP, if you were in the meetings this morning, that there was a White House position paper on the need for nature-based solutions. So they're taking this as an exemplar that to be able to not just develop an innovation hub, but an infrastructure that can support multiple different types of innovation that can do nature-based solutions for coastal resilience. So things like oyster beds, seaweed farming, new types of green riprap, pollution mitigation, et cetera, and basing that here at this location. The lessons learned that we did from those two previous projects is that we're applying system engineered design efforts, different operational and governance models that we're bringing to bear, different data models and IP that goes along with that, observational and test support. But again, the key here is that from the get-go, we're trying to manage the culture of this pipeline to be able to not only foster new innovation, but new innovation among the peoples themselves, sort of that almost a network-to-network approach. And this just gives you an idea of the different players that are already involved in this project. And the different cultures and perspectives that they bring that all have strength, but we're managing those explicitly as we move forward in this type of innovation hub. Thanks so much.
Thank you very much, Hank. Next, we have David Gottfried, who is the Director of the National Nanotechnology Coordinated Infrastructure, and a number of other things, you know, not just one hat. And he's going to speak to us from the American context.
Thank you, Jane. Nope. There we go. All right, well, thanks everyone for coming. So I'm going to use these few slides just to give you kind of an overview of the NNCI, as we call it. I won't use the full name anymore, just to save some time. And we are, unlike a lot of the research infrastructure that we've been hearing about, not a data-generating infrastructure, but rather a product or device-generating infrastructure where individual researchers, be they students, postdocs, faculty, industry folks, government folks, come in, use the facilities themselves to generate their own devices and or generate their own data if they're using data-generating technology. So we are a distributed network at universities. We are funded by the National Science Foundation, and we consist of 16 sites shown on the map there, some of us with partners, so it's actually about 25 universities in total across 16 states in the US, but 71 facilities, because many of the universities have multiple facilities involved, about 2,300 tools or pieces of equipment involved, and over 200 individual experts located at those facilities, because as we've heard earlier this morning, the human capital is just as important as the kind of physical capital. There are really three main goals of the NNCI program. The primary one is really to provide this open access to state-of-the-art characterization and fabrication facilities, including the tools and the staff expertise, to essentially anybody who wants access. The restrictions are very, very limited. Secondarily, and this is where some of the translational aspects come in, we use these resources to support education and outreach activities. That is kind of a part and parcel with NSF funding. We also look at the societal and ethical implications of nanotechnology research, and we have recently introduced in our second 5 years of funding efforts to support innovation and entrepreneurship activities of the researchers using the facility. And ultimately, the goal of any of these types of network approaches is we don't want to just be the sum of a bunch of funded research facilities, but really want the whole to be more than the sum of its parts. So just to give you a sense of the scale that we're talking about, so this is the first 8 years of our funding. We were funded starting in late 2015, so 2015 through 2023, about 43,000 individual users of the various facilities, 8 million hours. About 25% of users come from outside the host universities. That's what we mean by the term external, and you can see the breakdown between other academic and industry users. The map shows the US academic users and the institutions in which they come from. So that's not the 4,500 academic users. It's there's about 445 US academic institutions, and you can see below the map some of the metrics for those particular institutions. And since this is a session about translation, and again, I'll talk a little bit about translation at kind of the most basic definition, that of taking a lab approach to commercial product. These are just a very, very small subset of some of the companies that have worked at our facilities. Again, if you look at the bottom, you can see in a given year, it's over 2,000 users from about 800 companies. Again, about 2/3 to 3/4 of those companies are small to medium-sized companies. And you'll probably see some names on that slide that you might recognize. But again, translation is not just about commercialization, it's also about societal or scientific and societal impact. So we do look at publications. We saw some like data from Hank's slides as well. And you can look at the number of publications that have come out of our research. And again, with 43,000 users, the number of publications is not too surprising. We also look at how we support the greater research enterprise, the greater research ecosystem. And so we look at what research funding is used to support access to the facilities. The numbers I'm showing there on the slide are just the tip of the iceberg. There's a ton of very, very fine data underneath that, but it's about 2,600 in a given year, about 2,600 principal investigators that get about 4,000 grants and awards worth about $5 billion. And then lastly on this slide, and again, this is a subset of data, we look at how many degrees we award to users. Most of our users are graduate students, so master's and PhD degrees, but also bachelor's degrees as well. Now to get to the point of the translation again, we do have specific innovation and entrepreneurship activity, both at the kind of network level, but also at the local level. And there are some of the programs we've introduced. I'll mention just the NTech Challenge, this Nanotechnology Entrepreneurship Challenge, which is kind of a 7-week boot camp for undergraduate researchers. They do an online kind of introduction to entrepreneurship, and then they have a Shark Tank-like pitch presentation, and there are prizes awarded for the best presentations. At the local level, because we are a distributed network, everything tends to be very local and flexible. So individual sites within the network are free to customize their programs to fit their local environment. And so some have entrepreneurs in residence, some offer seed grants, some have connections to local incubators and accelerators, and some even have local fabrication consultants who are willing to do the work for paying customers. And I'll end up with this particular slide. This is an example from my own institution at Georgia Tech. So this is a kind of a poster child example of translation at the NNCI. So, and actually even going prior to the NNCI. So in the late 1990s, there was research done by a professor at Georgia Tech named Mark Allen, who was developing pressure sensors initially for jet engines. He later realized that he could adapt those for use in biomedical approaches, and he teamed up with a cardiologist to create a company called CardioMEMS as a startup company in 2001. Its first product launched a few years later for abdominal aortic aneurysm, and then it was bought in 2014 by St. Jude Medical. St. Jude Medical itself was bought in 2017 by Abbott, and now it's used for a variety of heart failure diagnoses. And on the right, you can really see the kind of the TRL 1 to 9 level of use of this company of one of these facilities, all the way from, again, basic research at the graduate student level, all the way up through clinical testing, but even after they launched their products and built their own clean room to create their products, to create manufacturable product, they continue to come back to the university facility to test new products because of the flexibility available there. And they also appreciated the training that we provided to their technicians. So I think that was the last slide.
It's a bit tight up here, so people are trying not to fall off the back. So last but definitely not least, I'm going to invite Aya Jorola, and I've got that kind of right, to speak to us. Aya is from the ICRI, which deals with atmospheric observations, and she is the Director General of that particular ICRI. So, yeah.
Thank you very much. Happy to be here and share our experiences on the developing a business model while implementing and constructing a European research infrastructure. So indeed, ACRIS is a pan-European research infrastructure. It provides and produces high-quality data and information on short-lived atmospheric constituents and on the processes leading to the variability of the constituents in both natural and controlled atmospheres. We provide data services and digital tools for the research community and outside the research community, access services to our facilities, technical services to our community and also outside users, innovation activities, trainings, expertise, and networking activities for our community. So ACRIS is a highly distributed atmospheric research infrastructure. We have 17 member and observer countries at the moment, and we are hosting more than 80 observational platforms, which perform continuous measurements on the atmosphere. And then we have, in addition, more than 30 exploratory platforms, which are for experimenting and campaigns on atmospheric dynamics and chemistry. These are supported by 6 topical centers for our different atmospheric domains or components. And we have a distributed data center that is the single data entry point to our data products and the data. So ACRIS aims to be, in addition to serving the research community and the scientists, also provide atmospheric observations for societal needs, like climate change, emissions in industrial hotspots, air quality in urban areas, atmospheric hazards, validation of Earth observations from space, very timely at the moment, or evaluation of models and data assimilation. ACRIS aims also to be a platform for innovation, and we can provide in our innovation portfolio training on demand or targeting specific user groups, design and co-design of cutting-edge instrumentation, equipment or procedures. Also exploration of instrument synergies among the community. Collaborative research activities, joint instrument testing in our central facilities, and improvement of measurement and retrieval methodologies for aerosol clouds and reactive trace gases. In addition to development of new observation techniques in our field within our community. But as we are a highly distributed European research infrastructure, so in addition that we have 17 member countries, observer countries, we are composed by more than 100 institutions or universities. And this creates a challenge for us as a research infrastructure, how to place us in this innovation landscape. What is our role in facilitating innovation? Because it is the universities, research institutions where the actual work is done, where the innovations are created. So we need to be very careful how we are defining ourselves and what kind of role we as a research infrastructure are seeking in this landscape. I have 2 examples of the innovation activities and the collaboration with private sector in our community and in our facilities. But again, these have been performed in these research performing organizations that are part of ACTRIS. One is in the space industry. So ACTRIS is co-developing a new instrument for calibration and validation for the EarthCare mission. And ACTRIS and EarthCare, they are also connected very closely to meet the extensive validation needs for the advanced EarthCare observations. So ACTRIS central facilities, that are the topical centers that are supporting our national facilities, are, especially in the remote sensing field, they are heavily involved in the calibration and validation campaigns in general. Another example is from the environmental sector. So this is a Green City Solutions City 3, a pollution absorbing vertical plant filter for mitigating air pollution and heat in the cities. You may have seen this because it is in several cities already available. So this is a combination of mosses, which are naturally powerful in absorbing pollution and particulates, and then plants which provide the shade that mosses need to thrive in an urban environment. And it also has a built-in watering and IoT monitoring system, which maintains and measures the performance of the living structure. And our Center for Aerosol in Situ Measurements has been collaborating with the company in the development of the City 3, providing the facilities for testing of the absorption efficiency. The most potential we see in the translation of research to practical solutions and innovation is really in our data and the data provision, which we provide a high quality standardized data on atmospheric field. And this is something that has a high potential to be used in innovation and in translation of research and science into practical applications. Thank you.
Now to the fun bit. So we've heard about things like a different funding model by being able to bring in half of your money from non-government sources. Congratulations. Supporting your people and knowing that the different people are required, a different skill set are required for innovating. It's different from the standard, what we would consider standard research infrastructure skill sets. We've also looked at different programs that have been put into place to support innovation across the ecosystems. And also, where does these coordinating bodies of research infrastructure sit when they sit on top of research institutes and national bodies? Where does it all sit? Who gets to send the bill? So these are all the questions that we've kind of touched on here, but I'm going to start with the curly question. What barrier to a company or a translation project have you seen in practice, and how have you tried to bash down that barrier? Anybody want to take that one first?
So, because all of our facilities are university-based, but we do, of course, work with industry users, any of that contracting to use the university facility, it has to go through a university contracting office. And it's not just, so did I say enough?
Okay, hands up. Yeah, okay.
So, and we're talking about so in the US, it is public universities, private universities, it's a mix of things. And so there are issues of IP, of liability, of insurance, all of those types of things. That time is required for lawyers to look at things. So that is one of the biggest hurdles. The other that I'll mention is one of our strengths of this facility is the flexibility of the tools. And so if you're a student, a graduate student, or a faculty member, you want to be able to try new materials or new processes on tools that are close to what you would find in a manufacturing fabrication facility, but still allow you to try things that you would never be able to try in an Intel fab. Industry wants exactly the opposite. They want one material in one type of machine, one process. And so balancing the competing needs of industry and academic research can be challenging.
Maybe I can add on this that for us as a research infrastructure, we are quite not so agile and not so fast. So for example, as we are providing access to our facilities that are highly appreciated by the private sector wants to move fast. They would like to have the facility available when there is a need. And we are not able always to accommodate these needs of the private sector because we are built for the scientific access based on the excellence of the research.
Yeah. It's on?
Yep.
I guess I'll answer that slightly askew, and that's sort of really developing the trust when you've got a lot of different different project team players, and how to be able to do that. So, in the example of Neon, we had, again, very strong components that were very construction oriented, very management oriented, very academic oriented, and to develop the tools and the culture to be able to trust each other really was the process that moved that forward. Corporations do that at the high level, at the corporate level, and have strategic development tools that we found incredibly helpful, both for things like developing and getting Neon back on track, or developing the Jerry and others. So it's some of those tools that being able to understand how you can talk across each other, having the particular respect and value in that process. And that's also really important when we consider indigenous knowledge and being able to go across other cultures that for value add. For example, work that Neon's doing and others in the Arctic. So having those tools and those tool sets to bridge those cultures and to develop the trust at the get-go really accelerates the process.
Yeah, I have the same problems. So maybe we have common problems. And so in my case, when I started our challenge, so it was very difficult to share the goal with the industries, because the industry's goal was not the use of our infrastructure. Okay, so that the point is how to translate the facilities role to the industry's vision. That's a point. So that we did that many times, so that the dialogue with the industries, so the executives, of course, and also the researchers. So the more than 3,000 times I did. So as a result, we can share the purpose to use the infrastructure in between the scientists and the industry's members. Then the 150 companies agreed to invest to our infrastructure.
I think we all want Misaki to come and talk to all of our industries too. I think that's a very valid point. We work in areas where we think we all have the same culture, but when we actually think about broadening that out to different client bases and different user communities, we don't all have the same culture. As you all know, Research Institute A doesn't like Research Institute B, and they have different cultures. But we do have to break them all down and start talking at the same level, because we have to share that vision and move forward in that area. When we talk about translation, it's technically, theoretically different from counting papers, counting PhDs, and so on and so forth. So what does success look like for research infrastructure when we talk about translation? How do we actually measure our impact in translation, knowing full well translation is moving something from level 1 to level 2? You've moved it along. But how do we look at that and how do we measure ourselves? Over to you. Anyone?
I'll take a stab. I mean, you kind of already, your question kind of included the answer a little bit, which is, so there are metrics, and I showed some of them in my slides. There are others. Again, we count patents. We look at, we try, and on the economic front, we try to look at jobs created, dollars, that flow back to the local economy. Collecting that data is really hard, especially if you're not an economist. And we've actually hired economists as part of our project to do that, and done it on a kind of a pilot level for the state of Georgia, where my facility is located, and got some kind of data that showed a specific return on investment for the federal dollars invested. But to do that on the national scale would be very, very difficult. So the short answer to your question is I don't have an answer.
Are we on?
Yeah.
Okay.
No.
If everybody's ever sort of from concept to construction to operations, research infrastructure, they all know it all goes through several near-death experiences. And it's the same as for innovation and translation. So there's non-tangibles that are there for success, that if you're able to transgress that through developing the skill sets and that cross and breaking down those cultural barriers, for a lack of a better word, to be able to move on and overcome those near-death experiences, that's also success.
Mm-hmm. Okay.
Maybe I can follow that my example as a European distributed research infrastructure, this is even more difficult. And it is difficult also that to identify that where the fame belongs, where the credits really belong, and what is the role of the research infrastructure in facilitating all this. So how we are, what we can, there are metrics, but what we can report as a metrics for the research infrastructure, and what is then for our community and the RPOs. And this is extremely difficult. But I also say that on a kind of annual basis, on a continuous basis, we are in communication with the private sector companies that are linked to ACTRIS and our facilities. And we are getting feedback from those, and we are in dialogue and discussion with them. So we get this kind of not on a daily basis, but on a yearly basis, this non-measurable feedback that how we are doing, how we are seeing as a research infrastructure.
Not to be flip, but you should claim every single success.
So in that case, so that we have just started as a new challenge. We have no model. So we are discussing. And always I ask to the industry members, you are not just user. You should commit to our challenge. That's what I am asking to them. So we are discussing about how to metric the outcome, not the output. Mm-hmm. Yeah. So we are start discussion. And maybe next time we can tell something.
Excellent. I'm going to open it to the floor. Do we have any questions for the panel before I start asking them really curly questions? Do we have any microphones? I've got one down the front. Thank you.
Thanks a lot. It's a question for Takata-san because the ecosystem is really interesting. And I was wondering whether you have, a large number of companies that have, buy-in into the project. Have you seen some connection between the companies being developed? They are using an infrastructure for their own interest, but have you seen that because they work around and with the infrastructure, they actually develop link together. And that would be an added value for them as well as for the infrastructure.
Yeah, so that's in our case, that's in addition to the industry's members, so that as I show you that we have the major 10 universities and the research institute, and they provide the human resource of the top scientist list, and we match one-to-one in between the industry and the academy. And in that case, we start to use a generic AI for matching. That's what we are doing.
Excellent. Another use for AI. I just want to also just make a very brief comment that when we're trying to measure what we do, it's really hard to measure a negative. What would have happened if we weren't there, it's really hard to measure. So everything we say, oh, this happened, but would have happened without us? Probably not, but we don't know. So I've got another question in the back there.
Thanks. I have two very quick questions to you. One is in the area of translation through service, so service provision. I think we all, when we talk about translation in academia, we talk about making products. But step between that is also a service. And a lot of infrastructures, of course, operate also not only as a place where you can come and do your experiments yourself, but providing expert service to it. So I wondered to which extent your facilities do that, and how do you see that model to be maybe more widespread as a step towards a impact and a lower hanging fruit, really, than the product development and commercialization? And second thing is, do you talk to not only clients, but investors who would buy the product of what you do? Because I think the key thing when we work on translation is to develop products or services that people will want to invest in and buy them off us. And if we involve them early on in the stage of designing of what we're developing, it might be way more efficient than developing something and then looking for someone to buy it off us. So just, yeah, these two.
Oh, I so want to answer that question.
Maybe I can answer to the first question at least. It's a very good point that you raised, that the expert services are actually what we do a lot for the community, especially for the instrument manufacturers. So it is actually a big role for us, but we are not necessarily measuring it in this way. So very important point to point out, and for us also to look into this as a one service, specific service for translating the science and the research and the data to services.
Yeah, so regarding kind of a service facility, so for us, for NNCI, about 90% of the activity that goes on is what we call on-site, meaning the researchers come, use the equipment themselves. The other 10% is this kind of service, what we call remote access, and it doesn't mean literally kind of remote from afar. It just means that somebody someone of the staff is doing the work for somebody else. But that varies from site to site. One of the kind of the unique features of the NNCI program is that, again, every site is independent and kind of an autonomous operator, and so they set their own rules. And depending on their local environment, they may have staff that can do that, have the bandwidth to do that, whereas other sites might not have the staff with the availability to do that kind of work, but maybe they have a local independent consultant who's willing to do that work. So it really does, there's a continuum of that kind of work going on. The second question was about
the investors, talking to investors early on.
So again, we're not producing the product. It's the individuals. It's whether they're, again, students, faculty, or external users that are making the product. What we should be doing, though, and this didn't come up in the question, was what we should be doing is facilitating those interactions between users and those ancillary services like incubators, VC, money. I mean, if I had an ability to do that, of course I would. But and other types of things that startups need. And that we don't do. We generally, we kind of stick to the facility.
I'd also answer that second part of the question as needs assessment, whether that's a societal or the communities that are going to be using the products, or the researchers and educators that are going to be using the products from their research infrastructures, are all baked into that process. They're assessed as a priori before anything is being developed. And in the case, say, of the Jamaica Bay project, a whole variety of community-based and corporation-based use cases were captured. And going into formal system engineering approaches to be able to understand what the flow through is to develop the infrastructure and the services on the back end. And then also using those communities to test and vet them.
So in addition to that, our facility case, our facility located in the university's campus. So the university campus can give us many opportunity to collaboration and the support the industries. That's what we are doing.
Questions? No, the online.
This is a little bit of a devilish question, perhaps. Can you be too big? Is there a right scale for this sort of activity? Would you be doing something different if you were sized into, say, thirds and competing with each other? That's a sort of question for David, I guess, but maybe also for Battelle.
So
can you be too big? Would it
what's
change?
the right size to be a
Yeah.
research infrastructure that has impact?
Yeah.
Do we get too big and too cumbersome? And therefore we can't react to what we're being asked to do in the translation space. I'm going to frame it on the translation space. For example, if I have a distributed network, I have a client who comes in who wants to do a process, but those machines are in 4 different places because I have a distributed network. They can't get onto the machines at the right process. The people are all distributed. It takes them longer to get what they need to do. If I had everything in one small dedicated facility that only did X, Y, and Z, they could get through that better. Is there an argument for research infrastructure having a smaller footprint to create particular services for particular client bases? I've completely rewritten your question. Sorry about that.
I mean, so we do some of that. So and again, you have to remember the United States is a big country, and so we are distributed, and most of the facilities that I'm talking about are very generalist and have broad capabilities because primarily they were set up originally to, service the local student and faculty population of the universities, and so those by necessity had to be diverse. But also, there are a few sites that were picked by the National Science Foundation to be part of this network specifically because they had very specialist approaches. So we have one site located at Virginia Tech that is a specialist in analyzing environmental and earth science samples, so minerals and rocks and that kind of stuff. We have another site in Kentucky that has particular expertise in additive manufacturing. But again, most of the sites are designed so that if you are, doing work in microelectronics or microfluidics or MEMS or materials research, you can find all of your tools. We very rarely have someone that goes from site to site to site to finish their project.
Anybody? Nobody else is willing to take that one on, sorry.
I don't think I can speak for Battelle, but in terms of the research infrastructures of say, Neon and Jerry, you can't do everything, right? So, and the use cases on the front end that are designed or the requirements that are captured will change over time, right? So as part of that formal structure, we have change control processes that can add additional components to it. Plus, we've got the capability in the case of Neon to add additional research and additional products, et cetera, if need be. And that can also clearly come from the private sector. However, in the Jamaica Bay project, that's all about adaptive infrastructure right from the get-go to allow a variety of different types of projects that can run through that pipeline and to have the facilities and the infrastructure to support that. And so capturing those use cases and and those needs is fairly complex.
So I'm now going to give our panel the last curly question without notice. Should research infrastructure do translation? This is a yes/no question as far as I'm concerned.
Yes, it should facilitate. So from our, it definitely should facilitate, support the translation of research to applications and practical solutions, definitely. But I was kind of reflecting also what was said here earlier, that can the research infrastructure be too big? I was thinking it more in this way, that can we put too much resources? Could there be a situation that we are putting too much resources on the translational activities and putting effort and resources on the innovation platforms, which takes a lot of resources from an organization? And can there be a risk that we are forgetting our core tasks, providing data and services to the scientific community? So I think this is a balancing of these activities, yeah.
Yeah, so I would say yes and agree with everything that was just said. And the only thing I will add is, again, if we take a very broad definition of translation, and I think that was in the abstract for the session, so things like, kind of education and outreach, again, that are kind of a mandated part of every National Science Foundation project. So workforce development is a very big catchphrase in the US these days. And so every individual that comes and gets trained to use the equipment in the NNCI facilities, that's education, that's workforce development. And so that's also translational activity, I would argue.
Yeah, in my case also yes. So in the research infrastructure must become some immersive platform to connect the industries and the societies with academy. Yeah, I believe, and I will do that.
No mean feat.
I would also mirror what Aya had said in terms of balance, because research infrastructure is charged with a specific type of scope, but that scope can include a process and a mechanism for innovation and translation. That being said, it cannot also be an open-ended problem, right? So, and if you don't do it, you become antiquated very quickly. So there has to be accommodations, formal accommodations to be able to do that.
Thank you very much. Can you please join me in thanking our panel? And now I believe it's time to get caffeinated again. Good work, everybody.